Fire in the hole. Today on Fro-Dog Arcade Repair we have a Sanwa PM1723. This item is a full monitor that I ordered off of eBay, and it arrived with shipping damage. As you can see from the photo series here, that the PCB itself is cracked pretty bad and in multiple places. I do have a parts chassis that has been robbed pretty thoroughly, but it does have a good PCB. So rather than trying to repair this cracked up board, we're going to see if we can marry those two together and create one good functioning monitor out of the two PCBs. Dear and lovely arcade monitor enthusiasts, we are gathered here today to witness the union of these two chassis. Here we have the broken and cracked chassis that did not survive the shipping. And here we have the eBay untested, unknown, completely raped and pillaged of parts chassis, but has a good board. What we have today is Sanwa PM1723. Now, I purchased a complete monitor from California and had it shipped. The tube and yoke survived fine, but the board did not. It was in its frame and sat in this fashion. The weight of the flyback here just acted like a giant lever, and when FedEx took to giving it a good thump and a drop, just kabounced it and cracked the board. You can see pretty hard crack, clear back into here, chunked corners off. Pretty rough number on that unit. The base frame I did glue back together right here and threw a little epoxy on, so we've got a solid frame. We'll take our two screws out. But my plan is, since I have a unit that is physically busted, one option is I can try to repair this PC board, and I thoroughly believe I can. But I do have this other unit that I was able to find on eBay at one juncture, and has been kind of sitting in my spares and parts box. The PCB is in great shape, it's just missing several parts. So my plan is to tidy up this board and bring all of the needed parts over from this board that was a complete and functioning monitor prior to its shipment. So I believe the person that I bought it from, they're another vendor in the industry, so when they told me the monitor was working, I have every reason to believe that it was. So we shouldn't have bad components over here, except for the need of a cap kit potentially, but or most definitely just based on age. But everything over here that's missing, that has been pillaged from it, we can swap, and we can do some basic tests and see if we can get it running. Now, the Sanwa also flagged on the board as a V21, Victor 21. The PM1723 is primarily found in the Capcom Mini Cute, which makes it a rather obscure chassis. Not a ton of them out there. If you need one, you really need one. If you don't need one, you don't even know what a Capcom Mini Cute is probably. But we're going to make a fully functioning monitor, and we can either replace components that we need to, rob them from chassis to chassis, but we're going to take our good PC board over here and make something happen. Now, I do notice that our new platform for our PC board is a 1723E as in Edward, and our damaged unit is a, it's on this back edge here, a 1723D as in David. I was really looking hard and scoping out across these two chassis to find a differential, and I haven't seen or found one. It might just be, year of manufacture kind of differential. So let's dive into it. Let's first try to identify what needs to come over from this chassis to make this one initially whole. And obviously the first thing is the flyback. This board over here is going to need a little work. On the bottom we see some trace work here, and these two transistors are unsoldered, but they have nice tall legs in them. I wonder if they're not replacements. Well, the ones over here have tall legs as well. So we'll want to clean this up, sort out trace repair and work that might need done here, and fix it in Fro-Dog fashion. But looking on the bottom side here, I can see there's some components missing based on the solder. First thing I see again is the flyback, but we'll probably leave it till last since it's the big heavy piece. I think the first thing I want to do is get this AC cord tail off and out of my way. Is one side, yeah, this is the striped side. Alright, got what's left of the AC cord off and out. And we might as well do the same thing over on this chassis. Be one less thing fighting us. Which also means I'll probably go ahead and pull the flyback off of the cracked chassis, just so that it's a little easier to manipulate, as well as the neck board, because our donor PCB does not have a neck board. It looks like all we got to do is get the flyback off to get the neck board out. So let's start with some screws. Now this particular chassis, the reason I took an interest in it, if you haven't figured out, I kind of like some of the obscure stuff. I mean, yeah, you know, there are tons of G07s and K7000s out there, and they need work too, and I'll, you know, have and or will make videos with those. But, you know, everybody's got a G07 video and a repair story or procedure. But I have found not a single video anywhere, and I searched to just try to find out, on a Sanwa PM1723, or even searching it as Capcom Mini Cute monitor. Now a little bit of research says that these could have popped up in some other Sega games. Specifically, there were some, not many, of the Sega hang-ons that might have had it. But either way, it leaves a pretty narrow pool in the world of available units out there. So I want to offer a Fro-Dog refurbished unit for the PM1723, as well as with tube and a yoke. I can also offer full repair services if you just want to mail a chassis. So that's where we stand. My cheap wick started out good, but then started losing some of its mojo. I really like the Chem wick. Chem wick's like 40, almost 50 bucks a roll by the time you get it shipped. The cheap stuff is like under 20 a roll. So, you know, if I'm doing something really heat sensitive, mission critical, like IC or something, I'll use the Chem wick in that environment. But, you know, lots of solder movement for like a flyback, I just burn up the cheap crap. And yes, that is the rosin smoke that got me coughing just a little bit. feel free to tell me in the comments that I should have a smoke eater. I'll allocute to that, but I still don't specifically want one or want to fool with one. I suppose if I was doing this, 40, 50, 60 hours a week, might be a different story. With my 40, 50 an hour a week day job, it means my exposure time's significantly less. Okay, let's see if that's enough to get that fly back out, or if it's got any other extra pins to go with it. Oh, we still have a little bit of cohesion going on here. Let's see if that helps any. There it is. Alright, and I don't need to mark the boards because, well, one's cracked as shit and one isn't. Not like we're comparing a couple and have to figure it out from there. Also find it interesting, got two wedges in here that look factory. And these wedges are like CRT wedges. But I think they're in here to keep the flyback from squealing and squalling. Do I see anything going on with this flyback? Because that's a slight bit of unobtainium. It's interesting that two of those pins had what looked like wire wrapped around them. Other than a little dirty dusty, I don't see anything going on with that one. Alright, let's get our flyback and our neck board off to the side. Now, aside from the flyback, what do we need to move between and twixt these two monitors? Let's just systematically start in a corner and work our way through all the components. Extra credit if you know the reference. Boop, boop. Alright, we're back with our Sanwa PM1723. We've got kind of a crusty board here. I'm going to go ahead and drill out the crusty area, and we're going to use the welding powder and CA to make some new solid board. So, nothing to lose here, but getting rid of some of the crusties. Alright, welcome back to Fro-Dog Arcade Repair. As you can see, I've cleaned the bench up a little bit. Got our board nearly completed here. Alright, we're back. I did find one other weak point on this board, and that is a slight crack right here. So what I'm going to do is I'm going to make some starter holes. Right on that crack line, so I can drill it, and then we're going to fill it Alright, I found 3 points. I'm going to drill it, and then I'm going to fill it with our CA and welding powder to strengthen that spot. There we have it on the bench, curing under the UV light. We'll have to move the light a couple of times to make sure we get everything. Alright, we are reassembled and all cleaned up and ready to go. We are back with our Sanwa PM1723 out of Capcom Mini Cute. We're going to stage 1 light bulb test this unit, prove out the power supply is working. The HOT is unsoldered and out of circuit, so we really just need to see the power supply section working. This is a 100 volt AC unit. This is a Japanese unit. It will not work on 110, 120 US voltage, so we need a Variac, or in this case a Vivorac, the knockoff Variac. Now, Variacs by nature are auto transformers, but they are not isolation transformers. So, since this is not a switch mode power supply, it's a traditional bridge rectified and regulated supply, it does require an isolation transformer. So my isolation transformer is ahead of the Variac, which then dials us down to 100 volts AC to feed the chassis. We have our test points. This 1E test point down here, I believe that E is for earth ground, and we have R809 as our other test point. It is this leg of this resistor, the leg closest to the large sandblock resistor. Now you can also clip on fuse F802. That's also our output of our DC supply, but we are ready to go. So after all of that work I've done on the board, building new board, drilling holes, repairing components, I'm hoping we don't see sticks and weenies, but here we go, firing the hole. Look at that, we've got a light bulb. We've got 115.7 volts DC. I don't see any smoke. I don't see anything cooking, anything doing anything weird. And all that repair work that we did down in this section is all power supply. So, or no, that's not power supply. It's part power supply, and part of it, I think, is our vertical deflection circuit, those two transistors. So we'll see if vertical works once we get it on the tube, but I'm excited. We've got our power supply section up and running. I guess our next step is a stage 2 light bulb test, and we'll get that HOT transistor soldered in. Here is the underside of our fixed board. I just got that HOT soldered back in for our stage 2 light bulb test. We've got the green UV cured conformal coating over our repair area here. This was the area that was all carboned up, crusty, cracking and crumbling apart, where I literally chunked out and dremeled out the board, laid a template, re-drilled the holes, and laid wire for traces to rebuild this section of the board. On the top side, we can't hardly see it because I painted it a similar color brown so it blends in. But I was really excited that our stage 1 light bulb test worked and that we had power supply functioning. You see, if you look down in there, it's a little rough in texture, but it's not all white like the welding powder repair is. So, again, we don't know what this is going to do on a stage 2 light bulb test. Our power supply is working, our horizontal output is good, and our flyback should be good. The monitor that this started as with the shipping damaged, cracked in half board was reported as functioning before I got it. So, fire in the hole. Alright, we've still got our light bulb. B plus is the same. Got our anode in our glass jar. But I am not hearing anything from our anode. Let's turn a light out and see if we see anything. Let's turn, well, we need the light bulb for the, being the analog load for the CRT. I am not seeing anything jumping across there. I'm not hearing anything. That does not mean that our high voltage section isn't working, but we can usually hear something. Alright, so I don't know if our stage 2 B plus test is a success or not. Let me take a quick break here and come right back. Well, it's stable. There's no smoke, no flames. Perhaps this chassis cannot be stage 2 tested. There's just not enough documentation or anybody's experiences with it to know. I think our real test is going to be to put it on the CRT with a yoke and some signal and see what truly happens then. Okay, we have our chassis mated back up with the tube and yoke. We've got our high voltage anode in place. Neck board, ground. Got our ground here. Got our power plugged into our Variac, which is piggybacked off our isolation transformer. This one will be fun to adjust. All the adjustments are down here in the front row against the bottom of the tube, so that'll be something fun to play with. But the first thing we want to see is, do we get high voltage? Do we get rast, or does anything come up? So, fire in a hole. I do not feel any static. Turning the screen, it doesn't do anything. I do not believe our high voltage came up. I also don't believe we have any neck glow. I'm not seeing anything. So, that's where we're at. The high voltage circuit is not coming up. So we'll dig into that and see what we got. Alright, we're back with our PM1723. Now, we have B+, and it adjusts properly, but we have no horizontal output. Our HOT is good. We just aren't getting any high voltage. So let's troubleshoot this. First thing we need to do is, I went back through with a meter and checked our HOT again. Looked for any open resistors leading over to it. Didn't find anything. So next is, do we have our horizontal drive signal? And looking at our schematic, I put this on legal size. IC301 is an HA11235. Now, looking at our schematic, find my pointer here. We have our IC. Now let's find our horizontal output and then our vertical pre-drive and work our way back. So, our horizontal output is here. Goes back through our transformer. Our drive signal comes off of Q304, which then ties back to pin 10 of our IC301. If we look, that pin 10 is going to have our 332 on it. It's going to have our 333 to ground, a 470, and a 680. So our horizontal drive signal should be coming off of pin 10. Should be a square wave. Let's look here on the board. There's our HOT. There's our transformer. There's Q304. So, if that's tied to that leg, that's tied to that. This is our base. It goes under our repair area here. Alright, so how and where does it go? It should get back to our 332 from there. So where is our 332 physically on the board? There's 333, and that makes sense. We're tied one leg there over to this ground plane. So our 333 is 680 ohm, quarter watt. Do we have 680 ohms? We're in our holder now. So on this little meter here is where we're going to do our measurement. There we go, 690 ohms. That resistor is good. So we've got to get from here back over to this chip. Let's find pin 10 on IC301. So IC301 is an HA11235, and I printed out a data sheet on it. And you can also see on the schematic that it has an uneven number of pins on each side because of these little heat sink ends. And when we look at our block diagram of the chip, we have our long side and our short side. Pin 1 starts before the heat sink, 8, 9, 10 ends after the heat sink. So this, we're looking at the leg side, so we're looking at the other side. Here is our short side, here's our long side. Our keyway should be here. So this should be pin 10. And look, there's our 332 right beside it. Okay. Our 332 measures 476 ohms, and according to our schematic, 470. That resistor's good. So the end of this resistor should, by traces, be tied to the end of R333. That doesn't seem good. 405K and counting down, like it's going through a cap. Let's see. 38K. Now it should be just directly there. Should be the same point electrically. So, I think that's our problem. I think we don't have connectivity from here up to Q304, our drive transistor, which goes through this transformer and operates our HOT. If we are not getting our square wave to HOT, then we are not creating high voltage. Before we get, I still think we need to find that connectivity problem, but let's look with our oscilloscope and see if we have our square wave output on 10. See if we actually have drive signal. Make sure this IC is good, and we just proved out the two resistors are good in the path. Let me get the camera out of the holder here. All right, there's our oscilloscope. I have it hooked up to power with our, first through an isolation transformer, then through our VORVAC, our Variac, and a light bulb on to give us a load. So it's just like light bulb testing it. We should be able to turn it on, get a light bulb, and then we should look for that square wave. We have power to the system. I do not hear anything but the meter telling me it's going to shut off soon. All right. So let's see if I can get the camera on the scope here. Let's look at pin 10. Aha! We have our horizontal drive. So we have our square wave coming out of IC301, and our disconnect is R332 to up to Q304. All right. I hate to say it, but I think my repair has to be in question here. I must have missed hooking up a trace or something on this board, but let's follow it out. Let's turn it off, kill the power to it. So we know we've got our output from IC301. We proved out our 470 ohm resistor. So now we just need to prove out continuity from here to here, which we do not have. So let's follow this pad. There's continuity. J11's a jumper. Continuity. J13. Continuity. Another jumper. J... No, 15, not 6. 15. Continuity. And then it disappears underneath our conformal coating and doesn't make it to here. That's our problem. I missed some sort of connection beneath this. Had to have. All right. And that should then get our square wave up to Q304. That will then drive our HOT. So if this works, we should get high voltage crackle. Fire in the hole. Oh. Oh yeah. Oh yeah. High voltage is sizzling away in there. All right. We'll put it back on the CRT now that we have high voltage. All right, we're ready on our tube and yoke. Now, I did not have this connector, so I just hard soldered a set of leads over that would plug into my test pattern generator. I just took the connector off the board. So, we have power, ground, other ground, high voltage anode, yoke, degauss is back here, and signal. Test pattern generator is on, so fire in the hole. We got the tickle claps, but we've got horizontal deflection now. Step at a time, brick by brick, my citizens. All right, let's talk about our vertical collapse, and let me tell you what I found. I went right back to the same place. This IC301, our HA11235, is our sync processor. It gives us not only our horizontal, but our vertical. Like our horizontal came out on pin 10 of this IC, pin 2 of this IC gives us our vertical out, comes through R323, the 680 ohm resistor, and goes over to the base of Q302. What I had was the same or similar problem. It was my error in repairing traces. When I started taking a meter looking for continuity, I had it over to the base. I checked the transistor itself, and it checked fine with our two junctions, base to emitter, base to collector. And then I thought, well, does our emitter go to ground? And it didn't. So what I found, and see if we can show it on the chassis here. Here is our emitter of Q302, and it should have had a nice heavy trace ground lug over to our big ground plane here, and there was not one. So I'm going to caution you all that when working on a multi-hour, multi-step process like marrying these two boards, chunking out carboned up, cracked, broken, brittle board and replacing it with the welding powder and CA, and then having to relay traces, you want to be as fresh as you can for that. I do a lot of my bench work after my day job, and I was doing a lot of that board work late at night, and I just wasn't as fresh as I should have been, and I missed running two traces before I got the conformal coating on. So there were two connections that were not made. One was the horizontal sync input signal to get to our transistor and through our horizontal drive transformer, and one as a ground off of our vertical drive. So I didn't even get the scope out and look for that sawtooth coming off the HA235 chip. I figured that it was probably another connection error or issue, and I was right. So I'm going to cut away. We're going to slide this chassis back into the frame here with the CRT, and we're going to light it up. Alright, we have our chassis, made it up with our tube. Got our high voltage anode, neck board, ground to the neck board, other ground, signal to our test pattern generator. Got our yoke connection. If you can see on through in behind that yoke connection to the far end of the board, we have our degauss coil. Not mission critical, but I like to plug them in. Power over to our variable transformer. Again, these are 100-volt chassis, so you cannot just plug them straight into US power, and you also must have an isolation transformer. So I have an isolation transformer ahead of the variable transformer. It's set to 100 volts, and we're all hooked up. I cleaned the tape and whatnot off of the screen so we can see a better picture. Fire in the hole. And there we have it. Horizontal, vertical deflection. Play with our focus just a little bit there. Bring that down to just our retrace goes away. Got a good looking checkerboard. Color bars. Our color drives need turned up a good bit. You can see they're a little mute there. We don't have the purest white, so it needs adjusted up, but we are functioning and we have decent geometry. Going to do all the tweak ups and adjustments for the picture and do that little bit of conformal coating over the two traces that I missed in the rebuild of the hole in the board, the burnt crusty spot. But we have success. We have our Sanwa PM1723 capped, fixed, working, and our two boards married together for one good chassis. And we have a CRT and a yoke that are specific to this unit. And again, Capcom Mini Cutes are the common source of these. And that red little flashing light is just a reflection of the LED display on my soldering iron. Thank you for watching, and I hope this gives you inspiration and whatnot. And if you need a Capcom Mini Cute chassis, you'll find this one on eBay. And if you need one repaired, I have familiarity with the chassis now, as well as I have a tube and yoke that I can fully test and dial it in on. Alright, I spent a couple minutes tweaking the picture up. Got nice crisp checkerboard. We got all our colors present, even our grays now down across the bottom. Got our width and position stretched out where they need to be. We got our vertical height. We've got good representation now of all three colors. Nice bright red, green, blue. Red, green, blue, solid red, solid green, solid blue, and a crisp white. Got our gray scale. Shows our gray between our blocks. And there's our geometry. So I am going to let this burn in on the bench for about 24 hours. And call this one a wrap. Thank you for joining me at Fro-Dog Arcade Repair. I hope you enjoyed the video, found it useful, or at least entertaining. Please subscribe below, like, follow, and share with your friends. And remember, fire in the hole.